Welcome back, guys. Today we're going to be working on the sleeves for the deadlift bar for CAPO states. So as you can see right now, we're set up, ready to drill out the inside of the sleeves. Then we can work on the outside, counterboring it for the bushings and bearings. Then, of course, finishing with the inner collars. So without further ado, let's go ahead and get into that now. Connect our coolant up. It's been a while since I've drilled sleeves, so I just want to make sure I'm set up correctly. Before I start drilling, I should probably just show you. So I've got a steady rest set up here, and the bearings are just very, very, very lightly touching the drill. Because it's such a long drill, and because it sticks out so far, it can lead to a bit of chatter and bad tolerances on the inside diameter of the drill. So by having the steady rest here, it holds this drill steady as I drill in, and I'm able to get a much better tolerance on the hole and also work a bit faster. So that's why that's there. Okay, so that is the first half of this sleeve drilled. I can now turn it around, then we can drill the other side exactly the same. I should have mentioned this in the intro, but this is 17.4 pH stainless steel. It's a very hard, high tensile stainless steel. It's 300 Brinell hardness and about 140,000 or so PSI tensile strength. So pretty difficult material to work with. Also, the diameter of the drill that we are using is 36.5 millimeters. The tolerance isn't too important here. The main thing is that the hole that is drilled is bigger than the barbell shaft that it goes onto. The barbell shaft is 35 millimeters. So as long as it's at least around 36, then I'm happy. So we'll go ahead and check that now. 36 on the dot, so I'm happy with that. I'll see if I can try and show you guys the inside. Considering how far that tool sticks out, it's a pretty decent surface finish considering how long that sticks out. So yeah, I'm very happy with that. This sleeve must be a bit bent, this raw piece of steel. I've never had so much trouble getting it to spin true because they're precision ground. I'll just give it a whack. There we go. I'll make sure this is very tight. Okay. Okay, you guys may not be able to see this, but I'm just putting some more coolant in the lathe because this uses up quite a lot and I don't want to run out halfway while I'm drilling. Sleeve 2, let's go. So that is now this sleeve completely drilled. Hopefully you guys can see that. That's the whole sleeve now drilled. Show you the other side. So yeah, that's the whole sleeve drilled. I'm happy enough with the surface finish. The entire sleeve is above 35 millimeters, which is the most important thing. It doesn't matter whether it's anywhere between 36 and 37, as long as it's around about 36 or more, that's all I care about, because as long as it spins freely on the bar, the bushings are what I machine to be precise to have a good fit on the bar. And with regards to the weight of the bar, obviously they have to be calibrated to 25 kilos on the dot for a squat bar or 20 kilos on the dot for a bench or a deadlift bar. And the way that I calibrate them is with the inner collars. So the inside diameter is not too important as long as it's bigger than the bar shaft. So that is sleeve 1 done. I'll now move on to sleeve 2. Okay, the inserts are still looking very happy, so we are ready to drill the next sleeve. Go ahead and touch this here very lightly and go. All right. I don't know if you can see that, but that is the first half of the second sleeve now drilled. I'll measure that now. This one here is 36.5 on the dot. So I'm going to measure it a little bit deeper just to make sure it's the same all the way through. So I've just measured that deeper on the inside, exactly the same. All right, so very cool. Now that we've drilled the first half of sleeve number 2, we can turn it around and do the other half. All right. And last but not least, that is sleeve number 2 completely drilled. Measure that, and that one is 37. Okay, so that is both sleeves completely drilled out within my acceptable tolerance of 36 to 37 millimeters. Now we can go ahead and machine the outside, do the thread and all the other bits and bobs to turn this now hollow stainless steel bar into a finished barbell sleeve. But before I do that, one thing I do want to quickly mention is some of you might be asking, why am I drilling out a bar that's solid when I could just buy a hollow bar? And the reason is because when you buy a hollow bar, the hole inside is not always straight. In fact, it's usually quite badly not straight. And I could get hollow bar and drill it out with a drill like this, but the issue is it still is not straight because this will just move around with the bend that's inside. And the other option, which would be buying hollow bar and boring it out so that it is definitely straight inside, well, you have to get a significantly long boring bar. It's very small, the length to diameter ratio is very high, so it ends up taking way longer than it does than to simply drill it out with a drill from solid which produces a straight hole. And like I said, I calibrate the bars afterwards, so even though this sleeve, as you might have known, it's slightly bigger than the other sleeve, it all gets calibrated anyway, so the entire bar is exactly what it needs to be, and it's not going to be heavier on one side or another. So I've tested all the different ways to do it. This ends up being the fastest and the best, so that's why I do it. All right, so we can now swap this drill out for, well, I've already got my external turning tool on there, so we'll just take the drill out because it's big and cumbersome. The next thing that we need to do is turn the outside diameter of the sleeves so that they land exactly on 50 millimeters. My tolerance for this one is plus or minus 50 microns, so it can be 49.95 or 50.05. Usually I get it pretty damn close, so we'll go ahead and set up for that now, then turn the OD. All right, so we need to set up our 2 centers because we'll be turning the outside diameter between 2 centers. That way we get a perfectly straight cut and the diameter is the same from one side to the other. Okay, now I need to change the insert here from this 0.8 corner radius to a 0.4. That's going to give me slightly better chip breaking, but also what the 0.4 allows me to do is have the profile of the sleeve be barbed. So kind of like the stinger of a bee, and that allows me to have the profile of the sleeve be a barbed finish, which means you can slide the weights on easily one way, but to take them off, it's a bit harder. That's good because when you're doing lots of reps, every time you put the bar down, it hits the floor, the weights clang around, and then they can slowly work their way off the bar, and that can make the weight feel heavier on one side or the other. So by having the sleeves barbed, the weights are less likely to come off because the collar, which holds the weights on, has to overcome that barbed profile in order to actually move and let the weights loose. So it's one other thing that we do that no one else does that makes our bars better. So I'll change the insert now. I just like to give this a little bit of a sand before I actually use it, because that way any high spots that have built up from the last time I used it get taken down and it's nice and symmetrical again. Okay, then over this side, we can swap this live center for another one that I made myself. I'm gonna give it a bit of a clean up because I haven't used it in a while. Just got a bunch of dust and stuff like that on it. Here is my steady pipe center that I made. It's also a live center, but I don't use the actual live center portion here because it's not as accurate as the one that I bought. But this part here is definitely pretty good. It's just to do the point, it was an afterthought and I couldn't get it absolutely perfect. So yeah, just for reference, it's probably 30 microns of run out on that point. I should have done this on the lathe, but I'm just chamfering the inside edge here of the sleeve because it gives it more surface area to contact on those centers so it grips better. I just forgot to do it when I had it in the lathe. So one goes up there, this one comes along here, like so. Then we do that up very, very tight. Ouch. From factory, these come precision ground at 50.8 mil, and I need to turn them down to 50 on the dot. So we'll go ahead and do that now. Set that to 0. And we need to be on LASW 1, very good. 800, okay. Gear is engaged, set that to 0, a little bit of coolant, and go. Woohoo! Now, before we do another pass, I'm going to measure it on this side and on this side, just to make sure that this center is lined up with this one. Because if it's off by even a little bit, one side is going to be smaller than the other. So I'll measure it, then I'll make the adjustment if I need to, so that the diameter is perfect along the entire length of the sleeve. 50.72, 50.71. So that is only 10 microns. I'm not going to bother moving this because that is extremely close. And if I try and move it, there's a chance I actually make it worse. So I'll just leave it. So 50.72 is where we are currently at. And so that will be my final pass. So I'll do one at 0.5, like so. And away we go. All right, go ahead and do another pass here. Okay, one more pass. So if you zoom up on this clean bit, you'll be able to see, you'll have to zoom in a lot and hopefully it'll show it on the camera. It's actually not a perfectly smooth finish. There's a tiny, tiny, tiny bit of chatter, which to me is unacceptable. No one else probably notices it, but I notice it. So I'm gonna slow it down to 305 RPM for the final pass. That will get rid of that chatter and it will be absolutely pristine. So I am just gonna measure that as well to make sure that the final pass is going to get us down to 50 mil where it needs to be. 50.28. All right, so we'll go in an extra 20 microns. Zero that. And we'll also use a lot of coolant this time. It looks like I have a coolant leak, which I'm going to need to fix. That's terrible. I hate when the swarf goes underneath the cutting tip, because if I pull it out, I ruin the surface finish. So I'm just gonna let it go. And I can't do another pass because this is the final pass. I do need to get it out. There we go. There must be swarf in the way. I can't get my coolant in at all. There we go. Okay. This type of operation that I'm just doing is very annoying when it comes to chip breaking, as you can probably tell. But no matter what I seem to try, you know, it's a very difficult grade of stainless steel. You know, the bigger corner radius would just be even worse for chip breaking. It is what it is. And I don't have enough money to just buy every single different insert. So the finish here is not perfect. I can feel a bunch of little bing bongs is what I'm going to call them. And I can fix those up with a wire brush and then polish the sleeve. But I'll clean it up first to see if it's actually necessary, because I can only just feel them with my hands. But if they're not visible, I'm not going to worry about them. Unfortunately, it's not quite acceptable, so I am going to have to polish it up. Okay, so first what I'm going to do is hit it with a wire brush, which is going to take off all these little bing bongs that I talked about over here. Then I'll hit it with a polishing wheel. Now straight away that feels a lot smoother, so now I will polish it up and then we'll be ready to go on to the next one. I'm just putting terps on it right now because that's going to take off all the extra polishing compound. Okay, and there you go. Now you can see that the sleeve has come up pretty much absolutely perfect, and any minor imperfections that are there are pretty much imperceptible. And yeah, now it's beautiful, shiny, lovely, smooth. And yeah, so obviously I don't always want to polish it like that because it takes quite a bit of time, especially when you're doing, let's see, 30 sleeves, it adds up real quick. So ideally I like to get the good finish when I'm doing the last pass with the actual tool. And I would say probably 70% of the time I do get the good finish with the last pass. It's just if I happen to get unlucky with the chip breaking at the start, I don't want to tear it out with the pliers because then it leaves a gouge in the sleeve that I can't fix. So I'd rather just let it go, let it do its little tiny imperfections, and those I can fix up with the wire brush and polishing. So yeah, that's that. Now we can move on to the second sleeve. See, that's the kind of chip breaking we're supposed to have. You can't get that kind of chip breaking on the finishing pass because you're taking off a smaller amount than that. Just trying to find the spot where the thread engages, because I'm using the threading gear to get the 1mm pitch. You've got to find a spot where it engages. All right, one more pass, drop it down to 300 RPM. And there we go. Just clean that one up. And there we go. That's how it's supposed to be. Beautiful finish right off the bat. Okay, cool beans. I realized I forgot to measure the other one. So I'll measure this one, and you already know that both of them are the same anyway. So 50.029, 49.99. So essentially a 30 micron, just under 30 micron gradient between the fattest and the smallest part. And the good thing is all of it is within spec. It has to be between 49.95 and 50.05. And so that's a 100 micron tolerance, and we got 30. So very good result there. Other sleeve is exactly the same. Now we can go ahead and do the thread for the inner collars to go on the sleeve now. All right, so we can take this center out of the chuck now. The cool thing is, I already have collars that are ready to put on the sleeves. They just need to be calibrated and drilled and tapped. But they're already machined to the right diameters, and the inside is threaded with freaking beautiful threads. Do you guys see those threads? Marvelous. All right, so yeah, we already got these made, and we just need to machine the sleeves to fit. It's been a while since I made these, but they should be 58mm, and they are 58mm. So I'm just going to be putting some Bryce shim stock around the sleeve to protect it from the chuck jaws, since we don't want to damage that finish that we have on there. And also be very slow and gentle when we're putting it in there. Okay, I was just giving it a couple whacks with my dead blow mallet to make sure that it's spinning true. Now we can tighten it up and start machining it ready for the collar. So I'm pretty sure the outside diameter needs to be 49 or 49.5. It's been a while since I made it and I can't remember. So the inside of this is 48.5, which means that this would need to be 49. Okay. The first thing I'll do is face it so that we have a fresh, flat face. Like so. Then we will very lightly touch the outside, which we know is 50. There we go. Set that to 0. Then we want to be taking off 1 mil. So I'll do 0.75 just to start with. Then I'll remeasure and take off the appropriate amount. So 58 mil is how far we need to go. And I will just do another pass at 0 here, because that feed rate was pretty high and left a little bit of a groove. So I'll just do a little bit again to get a proper reading. All right, so we can measure this part right here. That's our true reading, 49.19. All right, so we can move the digital readout in 0.19. There we go. Set that to 0, and now we know that's 49 on the dot. Yep. 58. Okay, then I'll just put a chamfer on the end here. Like so. Now we can measure this just to make sure it is 49. 49.009. Very, very cool. Now I'm going to cut a relief for the thread. So what I'm going to do is come to 52.5. And we're going to go 1.5 mil deep. A little bit swampy there, a little bit of chatter, but it doesn't matter because it's going underneath the inner collar anyway. I will just hit it with the wire brush just to make it a little bit nice. All right, now we can put our thread in. Now, before I start threading, I need to double check what the thread pitch is. I think it's 1.25 mil or it's 1, but you know, I'm not sure, so that's why I'm going to double check. Sorry that you guys can't see that, but it is a 1 mil thread pitch. We'll set it to LASW1, which is 1 millimeter thread pitch. Slow it down a little bit. We'll just slightly touch the piece to find our little 0 point. There we go. Set that to 0. 7.5 for the first pass. We need some threading oil. Pack it off. We'll do a pass at 1 mil now, and then we'll see how the fit is. Okay. So the thing about this lathe is I don't think its threads are absolutely precise, and for whatever reason the threading gear tends to make it go in and out just a little bit. So the longer my thread is, it gets tighter as it goes. See, as you can see now, it's gotten super tight. So even though it looked like it would fit good at the start, I actually need to take a little bit more off. All right, give that a test. So I am pretty confident now that this is going to be a good thread, because we're getting to the tight spot, and it is feeling tight, but it is still feeling smooth. Oh, that's telling me otherwise. Okay, no, we're still a little bit tight. The other thing is that there's probably tiny bits of swarf still in the thread. So I'm gonna do a spring pass at 1.2, and I think that should be enough. Okay, back to 1.2. We're getting tight. We'll take off another 50 microns. Because the thing is, it won't need much. Like, it feels tight now, but as soon as it's good, it'll go easy. And I'm gonna do a spring pass as well at 1.25. All right, still getting tight. Just gotta be patient. All right, so it's just dawned on me why I'm taking more and more off and it's not going on. Everything I said about the lathe, you know, how it doesn't make perfect threads is true, but I remember now, all of these collars are not made with the threading gear. It's made with the standard turning gear, set also to 1 millimeter per revolution, but they're not the same. One of them is slightly out. So this is 1 millimeter per revolution according to the turning gear. That's 1 millimeter per revolution according to the threading gear. So they're just slightly mismatched, which is why no matter how much I take off, it's still not going to go on. But it is an easy fix. What I'm going to do is I'm just going to turn from here all the way back to here and remove the thread, because it doesn't need to be there. As long as I've got enough thread to grab and bite and get the collar on, that's all that matters. Because like I said, we can calibrate the bars, which is why I use the collars right now are way oversized. I need to take heaps off of them to get the bar to be the correct weight. And that allows for, you know, if the inside is a little bit bigger or smaller than usual, or if the thread here I need to take extra off or not enough off, or so on. But you'll see now that I'll be able to take some off here and then it will go on fine. So I'll start here at halfway, a little bit before. Okay, so zero that, and I'll start by taking off 0.25. In fact, I'm gonna do 0.5 now that I look at it. All right, 0.5. All right, let's see how this goes. Okay, we're still getting stuck. Okay, so I need to take a little bit more off and take it off further. And there we go, just like magic. We now have the collar going on, nice and smooth. Take the collar off. Okay, so now we have completed the thread on the sleeve here. We can now go ahead, put the other sleeve in and thread that for the inner collar as well. All right, there we go. Now we've got it running true. We can turn it down, ready to thread. Very tight fit. Might be getting a bit too tight here as we go further on. Yeah, it's too tight. Okay, I'm just going to do a spring pass at 1.2 mil and that should be all we need. I might have got a bit overconfident. Yep, I sure did. That's okay. It's an easy fix. So unfortunately my confidence is coming back to bite me on the arse and I need to try and line up this now with the thread and do another pass. You're not gonna believe it. I got so lucky and I engaged it in the exact same spot. So, wowee, how about that? Okay, and that is absolutely perfect. Okay, now that both of the sleeves are threaded and they are able to receive the inner collars, I can now counterbore both this side of the sleeve and the other side of the sleeve, ready to take the bearings so that it can go onto the bar shaft. So we'll go ahead and do that now. All right, I'm back. I took a break and so I'm back now ready to bore the inside of these. I brought my lovely wife Crystal with me. She's just here to keep me company. And yeah, so I'll get into it now. You might not be able to see it on the camera, but earlier today I cleaned the lathe a decent little bit and it feels good because it's pretty much never really had a big clean. It's been cleaned a little bit here and there, but nothing like this. All right, so we'll grab our boring bar now and shove it in here. There we go. Okay, let me just check how deep I need to bore that. 49.5 deep and 30 on the main. Okay, so on this side, we need to counterbore it 30 millimeters deep. And the diameter needs to be 42 millimeters. So we'll just touch lightly there. Set the digital readout to 0. Connect up the compressed air. While she's grabbing my earphones for me, I'll just take a little reference. I'll do one small little pass, then take a measurement, That way I know exactly how much I need to take off. Now we can measure this, 36.33. Just double check that, 35, 36. It's actually 0.83, 36.83. So if 0 is 36.83, 17. Okay, so that is 37, 41, and that should make 42 on the dot. Okay, so now that I've taken my measurement and I know how much I need to take off to get it to 42 millimeters on the dot, we can go ahead and do that now. Okay, so I'm just going to measure it again before I actually finish it off. This should be 39 on the dot. 38.94. So if that's 38.94, then we need to do an extra 6.06. And then an extra 1.2 because we want it to slip in. Okay, now that is 42.012, which is literally exactly where we want it to be. So once we make the bushing, which will be 42 on the dot, that will slip in and it'll be a really precise fit. So as you can see, I also chamfered the edge there. So it's just, you know, looks really nice. So what I'm gonna do now is take out this sleeve, put the other one in and bore it exactly the same. How you been? Good. You're so good. You want cuddle? Okay. Okay, have a cuddle. Say hello, Bungie. Oh my God, that's very good. You're so good. We'll just touch that, get our 0, and away we go. All right, so that is the second sleeve counterboard. I can now measure that to see where it is. And that is only 5 microns smaller. Once again, right within the tolerance. Once I machine the bushing, that's gonna be a really good fit. So cool. Now we can cut the sleeves, we can turn them around and we can cut the sleeves to exactly the length they're supposed to be for the barbell, which I'll need to check what that is because I can't remember. 454 millimeters is how long the sleeves need to be. So I'll take it out, measure it now, just with a measure tape. It doesn't need to be absolutely precise. Then we'll make the cut and we can counterbore the other side for the sleeve mechanism. Okay, so currently the sleeves are at 474 and a half. So 474 and a half, they need to be 454. So we're gonna cut off 20.5 millimeters from this sleeve. And for the other sleeve, we'll have to measure that one again because from the supplier, they all come a little bit, you know, I order them at 475, but you know, they got to get their orders out. And so it's like plus minus a mil. So I have to measure each one individually. But this one is 20.5 mil. So we'll go ahead and cut that now. Okay, I'm just going to swap the external turning tool here for a parting tool. And since my 2mm parting tool is broken, for fuck's sake. Well, that's $600 down the drain. How fun is that? On the home stretch, what I was worried about happening, happened. I'm waiting on a new one. The new one, by the way, is fucking sick. I can't wait to show you guys once it gets here. But while I'm waiting on that, I'm gonna have to use my 4mm tool. All right, 20.5 mil. Let's connect up the coolant. Slow it down a tad. 305. Okay, set that to 0, and we're cutting off 20.5. Tighten this up to make sure the lathe doesn't want to go anywhere while I'm making a cut. Okay, there we go. Oh, that looks terrific on the end there. I don't even think I need to touch it. Right, swap to our boring bar, and then we can bore this for the sleeve mechanism. All right, so we need to bore this to 49.5 millimeters deep. So I'll just measure that cut we made, 36.67. I'm gonna double check that. It's better to measure twice, cut once. 36.67, okay. So 778797. Do we need the extra 1, 2? Okay, so 0 that, and that's 37. We need 42. Okay, this should be 39.5. 39.509. So we'll come an extra 0.01, set that to 0, and we know that is good for the final pass. Okay. .016. So literally spot on. All right, so this sleeve is now almost completely done. All that remains on this one is drilling and tapping and calibrating. So we're gonna take this out now, put the other sleeve in, cut that to length, counterbore it like so, then we can drill and tap both of them, and then they'll be ready. Okay, so for this sleeve, I'm going to bore it before I cut it to length because the boring bar is already set up and the digital readout is set up. If I swap to the parting tool now, when I go back to the boring bar, it's going to be sitting in a slightly different position, you know, like plus minus 20 microns or something, which means it's not going to be precise. So I'm going to bore the inside now, and because I need to take off 22 mil, instead of boring 49.5 mil deep, I'm going to do 71.5, since that's an extra 22 mil. So I'll show you. I will touch here. Since that's going to be my 0 point for the parting tool, I've set it to 0 there. Now I can go in 22 like this, set that to 0, and now when I bore, I know that all I have to do is go in 49.5 and it will be correct even once I've parted it off. .16, identical to the other one. All right, so now we'll swap to the parting tool and cut off that 22 mil. Slow it down to 305 RPM. And we're going for 22 mil. Cool. All right, there we go. All right, so now I'll just swap back to the boring tool just to chamfer those edges. Okay, and there we have both sleeves perfectly cut to 454 millimeters long, counterbored on both sides to 42 millimeters exactly, just over about 10 microns. Actually, I need to make the end caps first. So the end caps are made of 304 stainless steel. So we'll cut those to the right size, and then we'll jump over to the hydraulic press to press in the logo. I also forgot I need to make bushings for these sleeves. I did make them before, but I made them the wrong size because I just got confused on the sizes, but it's not a very big task. It won't take very long. So we'll go ahead and set up the material now, ready to make a couple more bushings. Now that we have our material set up in the lathe, we can go ahead and start making these bushings. So the two bushings we need to make are 30 millimeters wide. The outside diameter needs to be 42 millimeters on the dot, and the inside diameter, I believe, needs to be 30.38. Needs to be the same as this one. And yes, 30.38. So I'll just measure the inside here, 29.92. Okay, so 0.08 makes it 30. Then we need 0.38, 238. Okay, so that gives us our inside diameter for these bushings. Okay, now that I have the inside diameter machined, I'll go ahead and measure that. 30.381, so that's very, very, very good. Now I can go ahead and turn the outside diameter using the boring bar. So what I can do is turn the digital readout to 30.38. And I know that that there now is in the exact center of the piece. And I want the outside diameter to be 42 on the dot. So then I can wind this back here to 42. Then I can turn the lathe in reverse, and that will allow me to turn the outside of this stock using the boring bar. Okay, that's got a little bit of heat in it, so I'm just going to cool it down before I measure. Now we'll measure the outside diameter. So this finishing pass that I just did here should be 42.5. I wanted to do the finishing pass a little bit big just to make sure that I actually finish on 42, because I'd rather, measure twice, cut once. So that is 42.49. So I'll need to take off 0.49, which means that I just need to change my 0 to 0.1. Hang on. Oh. So I zeroed it before my last pass, and I forgot that I'd done that. So I just took off like 30 microns thinking I'd taken off half a mil. Okay, so we're currently at 42.47, so 42.45. All right, so I'm going to take off 0.45, and then I'll hit it with sandpaper so that it lands right on. .11, 42.09. So apparently I did not account for the amount of flexion that, for whatever reason, seems to happen a lot more when I'm making these 4140 bushings than when I'm doing anything else. Maybe it's just because of the stick out of the boring bar compared to a real rigid tool. Anyway, so I've got to take off another 0.11 mil. Should have measured before I did the sandpaper. I just wasted a little bit of time. Anyway. Third time is the charm. 42.015, 41.998. So 15 micron difference between the smallest and the largest. All of it is within spec. That'll all go in just beautifully into the sleeve once I part it off. So we'll go ahead and do that now. We would just swap back to the boring bar for a sec because we need to chamfer these edges just here. All right, over to our parting tool. This one will bump up to 305 RPM. There we go. And that is bushing number 2. Okay, now that we have both of the bushings turned to the correct diameter, inside, outside, and width, I'm going to put them back in the lathe, except they'll be facing the other way just so I can chamfer the other edges of them. Bushing number 2 going in. So they're both ready to go on the bar now. Okay, now we have both of our precision bushings machined. These are ready to go on the bar. The next thing I need to do is make the end caps for the sleeves out of stainless steel and then press the logo onto them. Okay, so here I have a piece of 304 stainless steel, and this is going to be what I turn into the end caps. So each end cap is 15 millimeters wide by 42 millimeters in diameter. So we're going to need, let's see, 15, 30, 40 millimeters of stick out. Yeah, 40. So 45 is good. I prefer a little bit of extra. 45, cool. So this is currently 44 point something on the outside diameter, and we need to turn it down to 41.8 because once I press the logo onto it, it actually expands a little bit. So I'll go 41.8. I'll just measure that now so I know how much I need to take off for my final pass. 41.89. So I just need to take off 0.09 mil. Okay, now we can face it, and hopefully this insert does a good job. Sometimes you need this face needs to be absolutely perfect since this is where the logo is going to be going. That is wonderful. Okay, marvelous. Okay, now that I think about it, it's been a while since I made these, because last time I did it in a really large batch. I'm going to press the logo in here, and then I'm going to come back here and part it off because, again, because the logo is not a circle, it's a triangle, it doesn't expand it evenly here. So I'll push it in, then I'll put it back in the lathe, then I'll part it off so that both sides perfectly flat with each other. Otherwise, once I press a logo in, it might warp it a little bit, and that can cause the sleeve on the bar to get hard spots when it rotates, and obviously you want it to be rotating smoothly and evenly. One thing that I do need to do is face the other side so that that is parallel to the face we just made. Otherwise, again, the logo won't be stamped in correctly. Okay, one thing I'm concerned about is this hole that I have here from my previous project. What could happen here is when I try and press the logo in here, there's nothing supporting the piece in the middle, so the middle might not get stamped as well as it should. Anyway, I'll deal with that when it comes to it. Okay, so here is my logo stamp. Okay. I'm pretty happy with that alignment. And we'll turn it 180 degrees and do the exact same thing. Okay, that was marvelous. Check that out. And there we have an end cap stamped with the Achievement Apex logo. So now we can chamfer the edge here, part this off, and it should be good to go into the barbell sleeve. Okay, so after I part it off, I'm then going to face it again, push the logo in again, and then I'll have two end caps. Very small chamfer. It's just dawned on me that this is supposed to be 12.5 mil, not 15. So I'm going to come across 2.5 mil. I got it confused with the power bar inner collars, which are 15. This is 12.5 for sure. Okay, there we go. And there we have an end cap parted off. So unfortunately, I did sacrifice 2.5 mil of the stock here, and that's going to need to be cut off, and I hope I have enough room there to fit the parting tool to get another 12.5 millimeter end cap. you guys are curious, I am using 35 metric tons of force to stamp in these logos. There we have the second logo stamped in. Now we can part this off. Now we have 2 end caps with the Achievement Apex logo. We'll go ahead and put these back in the chuck now and make this side look nice. All right, I've just finished off at the disc sander, and now I have 2 end caps ready to go in the barbell. This side doesn't necessarily look pristine and beautiful, but it doesn't need to. It's on the inside of the bar. The most important thing is that these are flat, which they are. So, or rather that they are symmetrical. Obviously you've got this spot here, which is a tiny bit higher than that, but as long as it is perfectly symmetrical, when it pushes up against the thrust bearing, it's going to be good. So yeah, there's our 2 end caps. These are now ready to go in the bar. Now that these are done, I'm going to go ahead and put these in the bar, in the sleeves, and they will now be ready to drill and tap for the final assembly. Then once we've drilled and tapped them, we can then put the stuff on the scale and calibrate it before assembling.